Chapter 2, Multiple Integral. First, we look at our subtopic double integral. Properties of double integral. We have 4 properties here. The first one is constant multiple. When we multiply our constant c here, okay, so you can bring your c to the outside of the double integral here. Okay, like this. Okay, the second property, sum and difference. Okay, so the properties, you can split your integral here into 2 parts. Okay, when you have plus or minus in between two function f and g here, so you can split into 2 integral. Okay, so domination here we have, okay, so double integral f okay, double integral f is greater than 0 if f function is greater or equals to 0 on region R. Okay, for B also just the same thing here. If the double integral of, okay, if the function f is greater than function g, then double integral value of f is greater than or equals to double integral g. Next property, okay, so we can split our region R into 2 region R1, R1 and R2 here. Okay, so summation, additivity here. Okay, so if our R equals to R1 union R2 and R1 intersect R2 is empty set. Fibonacci theorem for rectangular region. Okay, so we have rectangular region. How do we know that we have rectangular region? So we look at our region R here. Your x is in between A and B. So constant, constant. Okay, the same goes for y in between C and D, where C and D also constant. Okay, if it is bounded by 4 values of constant here, means that we have rectangular region. Okay, so here is our double integral. Okay, so we have our x here in between A and B. Okay, so x in between A and B. Okay, let's say here is A and here is B. Okay, we know that our P is greater than A. Okay, so it between A and B here. And then Y is in between C and D. Y is in between C and D. C is less than D. So Here is C. Here is D. Okay, so the region R is shaded here. Okay, here is our region R. Okay, so what happens here when we perform double integral over function f here, so let's say we have a surface here, looks like this. Okay, means the top of the okay, the double integral here shows that the double integral equals to the value of the volume of this solid. Double integral equals to the volume. Okay, with base region R, and the top of the solid is covered by the function f. Function f of xy. Okay, let's look at our example here. We are going to evaluate the double integral. Okay, first of all, we integrate with respect to y. So circle your y. Okay, x here is a constant, so you just write x here. So y becomes y squared over 2. 8 is a constant, so 8y here. Okay, then you substitute the value 0 and 2 into your y. So x 2 squared over 2 plus 8 times 2 minus x 0 squared over 2 plus 8 0. Okay, simplify. Okay, now we are going to integrate with respect to x. Then circle your x. So 2x squared over 2 plus 16x. Then substitute the value. 3 squared plus 16 times 3 minus 0 squared minus 16 0. Okay, so 9 plus 48, which is equals to 57. Okay, look at our next example here. Evaluate the double integral over the rectangular region R. Okay, so Okay, so we want to perform dx dy or dy dx. It doesn't matter, we'll give you the same answer here. Okay, the limit, if you have x here, so the value of x should be on the first integral here. Okay, x equals to -2 equals to 2, y from 0 to 2. Okay, now integrate, okay, with respect to x. Okay, y is cubed over 3 to dy. Okay, simplify, substitute the value. Okay, minus. Okay, now simplify. Okay, now integrate with respect to y. Okay. Y squared over 2. Okay, now substitute the value. Okay, you can bring your 16 over 3 here to the outside because it is a constant. Also 2 here you can bring outside. So 1 over 2. Okay, now substitute 2 into y, so 2 squared minus 0 squared. Okay, so 2 times 1, 2 times 8, 8 over 3, 4, so we get 32 over 3 as our final answer.